So in our next session, we are going to start the applications of electron diffraction. Wait till I'm sharing the screen with you. I think screen is visible to everyone. Yeah, trying to share with you. Yes, it is right here. And the next point from our syllabus is in front of you, which is very, very interesting one, and that one is applications of our electron diffraction. Yes. And as I told you just now, applications of electron diffractions are very wide range applications. So, electron diffraction can be used to determine the structure and the geometrical determination of SiF4 molecule structure and the geometry. Now, some of the students may get confused with the heading of my applications of electron diffraction, and that is, ma'am, you told us in XRD class that is XRD is useful to determine the structure and the geometry of the solid molecules, but why you have been mentioned here that is structure and the geometrical determination of your SiF4 molecules? So please guys, do not get confused with structure and the geometrical determination. Means here is the differentiation between your structural and the geometrical differentiation. And what is the differentiation that I'll be showing you? See, as we discussed, in electron diffraction, we took the graph onto photographic plate, and that graphical representation which is onto a photographical plate, that we can determine by using a graph, and that graph is like I versus theta. You can say that is as I versus theta, whereas I is the scattering angle and theta is the scattering intensity. झोपा सगळे, झोपी जा. What is I?
नाही मॅम स्कॅटरिंग
मग
इंटेन्सिटी
मग चुप्प बसून काय ऐकलं तुम्ही? व्हॉट इज आय? आय इज स्कॅटरिंग अँड स्कॅटरिंग. अरे झोपू नका ना.
इंटेन्सिटी
Intensity. And what is
and
theta?
theta is
What is
scattering angle.
very good. ओके 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 ओके. व्हेरी गुड व्हेरी गुड. आहेत म्हणजे आहेत काही जण मोबाईल लावून गेले नाहीयेत. तर जसं मी म्हटलं, scattering angle and the scattering intensity, that is I is intensity and theta is angle, and now this we can measure as I show you, like the with increase in the scattering angle, decrease in some maximas and some minimas were there in our scattering angle and the scattering scattering intensity. Some minimas and the maximas were there with increase in the scattering angle. सगळं काही रिमाइंड होतंय का बघा प्रिव्हियस क्लास मध्ये जे काही आपण शिकलोय, that is in our what viral equation. Okay, so let us come to the point. And what is that? Scattering angle and the scattering intensity, by through which we can calculate the distance between SiF molecule between sorry. Yes. With the scattering angle and the scattering intensity, as you know everyone, that is what we are determining, structure and the geometrical determination. Wait beta, structure and the geometrical determination means that geometry, how is it, whether it is square planar or whether it is tetrahedral. By using cone, तुम्ही की मी दोघं पण नाही, आपण कोण electron diffraction by using what oh, I think screen is visible too. Shit, what happened? Shit, what's going on? What is that? electron diffraction. What it we can determine it with electron diffraction. And how we can determine it? As I told you just now, remind my words. And what is that? By using D. And what is D? D is nothing but the interatomic distance. And this distance and the other calculations of that geometry of SIF4 in our SIF4, मतलब वो theta, sorry, गलती से थीटा बोला मैंने. It is that is interplanar spacing. That is what? Interplanar spacing. And whatever this interplanar spacing is there, this interplanar spacing is representing or is used to determine the regular geometry of SiF4 molecules. SI कोण? F4 molecules. And that SiF4 molecule कोणत्या color ने काढू रे? Si आणि 4 fluorine atoms are there, which are situated like this. And as everybody can know or can visualize easily from the diagram, and that is these this geometry is nothing but the tetrahedral, is nothing but the tetrahedral, or you can show it is as TD. It is as TD, as you have been discussed in inorganic chemistry, in group theory, as well as in electron diffraction. Is that clear to everyone? If yes, then please tell me so that I can continue with the next. Yeah, okay, guys. Thank you so much. Yeah. Now, this one is quite interesting again. आणि हे तुम्ही ना तुमची ग्रुप थेरी शिकली म्हणून अजून छान तुम्हाला लक्षात येईल पहा. So, structure of B2Cl4. Structure of कोण? B2Cl4. And whatever this B2Cl4 is there, this B2Cl4. This B2Cl4 study we can calculate again by using electron diffraction technique. And this electron diffraction technique can explain us about this symmetry. Just listen my words very, very carefully. What for we are learning electron diffraction? Is it important or not? That you please tell me after some time, because I'm telling you the application, not only I'm telling you the how can we use, or how can we what is the principle of that electron diffraction, or I'm not just telling you about its measurement technique, but also we are determining or we are discussing about its applications also. And whenever you are very clear with the applications, then and then only your interest can be clear or interest can be increased in your studies. And every time try to take out or try to find out what is the application of a given point in your studies or in our chemistry. Then only you can apply that point in your future purposes. And if once you are clear with the application, then only you can be able to apply it in your future. And then only you can be a great scientist or a great teacher, or you can say a great lecturer, or a great what you can say, that is a great what is that a PhD student or a researcher, and a great chemist also. Okay, guys? So try to always find applications. Okay, now let me come to the point. By using where I was on electron diffraction technique. So electron diffraction techniques are very, very important, or it is very, very useful. And that electron diffraction technique is also telling us about symmetry of our B2Cl4 molecule. Symmetry of our B2Cl4 molecule. See, this is right here. It gives us कोण तुम्ही की मी दोघं पण नाही. Who's that then? Electron diffraction technique tells us. Am I audible? Hello? Am I audible?
Yes, ma'am. Yes.
Yes, ma'am. Yes, ma'am.
Okay, then please do not unmute yourself, because when you are unmuting na, at that time one of the sound beep is there, and then I think that you are not able to audible to me. Okay, so try to mute yourself all the time. Let me come to the point where I was on electron diffraction technique is useful to give the symmetry, to give the symmetry of B2Cl4 molecules, and it is used in the calculation, in the conclusion, to determine the X-ray diffraction analysis, and whatever this X-ray diffraction analysis is there, that is holding the point, and that point is nothing but the group theories. It's a point group, and or you can say that is a group symmetry. Group symmetry. And what is the group symmetry for your given molecule? That, and that given molecule is B2Cl4. It is nothing but the D2H. And this question they may ask you in your MCQ, that is by using electron diffraction. By using electron diffraction, can you determine the cis and the cis, can you determine the structure and the geometrical determination of your Si4 molecule? Can you determine the structure of B2Cl4 molecule, or can you determine the symmetry of your molecules? And last option can be all of the above. So which one option you will be choosing? You'll be choosing obviously the last one option, that is D option, which is all of the above. And now with this you can also study the vibrational frequency mode. You can differentiate this molecule by using also a vibrational frequency method, that is in IR method also. मतलब सिर्फ इलेक्ट्रॉन डायफ्रैक्शन से आप ये कंफर्म कर सकते हो क्या? तो इलेक्ट्रॉन डायफ्रैक्शन से मदद मिलती है आपको, मतलब एक ही डायफ्रैक्शन पैटर्न से ही आपको सब का सब उसका कच्चा चिट्टा समझ में आएगा क्या, उस मॉलिक्यूल का या फिर उस कॉम्प्लेक्स का? तो आपका आंसर होगा नहीं। तो किस किस डायफ्रैक्शन सॉरी किस किस मेथड से आपको आप डिटरमाइन कर सकते हो ये मेथड या फिर ये इंफॉर्मेशन आपके मॉलिक्यूल की? तो इट इज ऑन द बेसिस ऑफ XRD, on the basis of electron diffraction, and as well as on the basis of a vibrational frequency method, that is as IR frequencies, or you can say that is as IR method. Are you guys clear up to this? If yes, then please tell me, and then I can go for next point.
Yes, ma'am. Clear. Yes, ma'am.
Okay, thank you so much. Okay, thank you so much for informing me. And now again come to the next point, and that point is very simple one. आणि हा point ना थोडासा महत्वाचा आहे बघा, कारण तुम्हाला हे असे पॉइंट्स आता मला माहित नाही तुमचा वायवा होणार आहे की नाही, पण समजा, but suppose if you are going for an interview, and interviewer means not only for viva but also for your interviews which you may appear after your MScs, once you crack your set exam, net exam, get exam, and if you want to take an admission for PhD in ISER or IITs, any IIT institute or ISERs, or any other countries, any research institute, then they may ask you what are the applications of electron diffraction, what are the applications of XRD, what are the applications of neutron diffraction, what are the applications of IR, UV. ऐसे डायरेक्ट भी पूछ सकते हैं और इनडायरेक्ट भी पूछ सकते हैं। कैसे? तो अभी अभी जैसे मैंने आपको पढ़ाया कि whatever our B2Cl4 molecule is there, that B2Cl4 molecule या फिर आपके मॉलिक्यूल के फ्रीक्वेंसी से आप कौन सी स्पेक्ट्रोस्कोपी बता सकते हो? तो उसका आंसर आप बोल सकते हो इट इज IR फ्रीक्वेंसी, और इट इज नथिंग बट द IR स्पेक्ट्रोस्कोपी। एंड देन आफ्टर प्रोटॉन का एनवायरनमेंट आप किस पर से दे सकते हो? NMR स्पेक्ट्रोस्कोपी के ऊपर से। सो ऐसे डिफरेंट डिफरेंट क्वेश्चन, बहुत सारे ऐसे क्वेश्चन है जो आपको इंटरव्यूज में पूछते हैं। इसीलिए मैं बोल रही हूँ एप्लीकेशन पार्ट बहुत जरूरी है। एंड अगर से आपको ना लाइफ में आपको किक मिलनी बहुत जरूरी है बेटा। एंड ऑलवेज ट्राई टू गेट मोटिवेट। डिमोटिवेट अगर से आप हो रहे हो, Oh shit. Screen is visible?
Yes, ma'am.
हाँ ओके सो अगर से आप डिमोटिवेट हो रहे हैं ना तो उसको मोटिवेट करने के लिए मैं आपको कुछ बोलती हूँ बट उससे पहले लेट मी कंटिन्यू द पॉइंट एंड इट इज स्ट्रक्चरल दैट इज दिस थर्ड एप्लीकेशन ऑफ अपर ईडी and that is structural determination of disulfone. Who's that? Disulfone. And whenever you have that disulfone molecule, that structure you can determine very easily by using electron diffraction. Then after by using electron diffraction you can calculate the useful हे जे ऍप्लिकेशन सांगतेय ना मी हे ऍप्लिकेशन बऱ्याच ठिकाणी फेमस ऍप्लिकेशन आहे दॅट इज इंटर ऍटॉमिक डिस्टन्स ऑफ SO2 आता मला सांगा इंटर ऍटॉमिक डिस्टन्स तुम्ही कशाने कॅल्क्युलेट करता रे बघूत कोण कोण बोलते इंटर ऍटॉमिक कॅल्क्युलेशन कॅन बी कॅल्क्युलेटेड बाय युजिंग काय
Wall equation.
Yes, it is by using viral equation or viral म्हणा, viral म्हणा, काही म्हणा. पण लक्षात ठेव. So what is that? By using viral equation, you can calculate the D, and that D is helping you to determine the structural determination of SO2, and it is very famous one example or famous one molecule, which whose structural determination have been proved by ED, that is electron diffraction. Okay, guys. Then after we can calculate the our structure and the geometry of our complex ions structure and the geometry can be determined structural geometries can be determined by using ED, that is electron diffraction. Now you may ask me मैम complex ion या फिर complex molecule मतलब क्या मतलब कि बहुत ज्यादा बड़े बड़े molecules like proteins like vitamins like complex inorganic complexes and like these जो कुछ भी आपके कॉम्प्लेक्स मॉलिक्यूल्स होते हैं इन कॉम्प्लेक्स मॉलिक्यूल्स की जो कुछ भी स्टडी होती है ये सारी की सारी स्टडीज हम कर सकते हैं हमारे इलेक्ट्रॉन डायफ्रैक्शन के हेल्प से नाउ you guys please tell me are you clear or not
Yes, ma'am.
yes
Clear.
Yes, ma'am. Yes.
everyone are you sure and if anything is not clear do let me know I'm always ready to solve out your any difficulty or any doubt anytime. I'm right there. Solve your any query or any doubt or any problem, difficulty, whatever you say. Yes, if it is, tell me. I'll be happy. Yes, it is about X-ray, huh? Hmm? Hello? Are you guys listening? Are you guys
Yes,
clear?
ma'am.
Okay, so I'm considering your words, I'm taking your words, and here I'm just ending this session.